In this video, I'm going to show you how to calculate adjusted standard errors so that they're more accurate when you have heteroscedasticity in your data. And the procedure is one that's provided by Hayes and Kai in their 2007 Behavior Research Methods paper. So you'll have to find this paper, and at the end of the paper, you'll see that they provided some syntax. And what you have to do is you have to copy and paste that syntax into a syntax file, which I did here. So I just literally, you can start a new syntax file. Let me file, new syntax, and then paste that material that you took from the appendix, and just keep going. Keep going. It's a full page on that one. Copy, paste, and then you've got one more page to go. Whoops, I think I made a mistake there. So it'll take you a bit of time to make sure you get it right, and if I actually remember to do so, I'll actually put a link so that you can just download the syntax that I created. That's what I did. I created a syntax file in that way, and this is what it looks like once I actually had it all inputted, copied and pasted. And this is a macro. So I need to run this macro to put it into SPSS's memory, if you will. So once this is in memory, I can actually execute the macro. So I'm going to run the entire macro, and now it's put it into memory for SPSS, and I have to start a new syntax file to execute the macro. And what you need to put in there, so I've just mentioned here that I'm going to run the Hayes and Kai macro. I did that. And now I need to execute the macro with a syntax command. And the syntax works in such a way that you specify the dependent variable, earnings per day, and then you specify the independent variable, education. And this term here calls the macro. So I'm going to copy and paste that, and I'll point it out again. So I just copy and paste hcreg, which is calling the macro that I just ran and put into SPSS's memory. And the dv, dependent variable, you literally have to write that. So if I were to do this from scratch, hcreg dv equals whatever your dependent variable is. And in this case, it's earnings per day. So earnings per day, and then a backslash independent variable iv education. And the syntax file is going to call the macro, and this is the data file I'm working with. So I've got education and earnings per day. For your research paper or whatever you're working on, you'll have different variables. You just have to know which one's the iv and which one's the dv, the independent variable and the dependent variable. And so now I'm going to run this syntax that I have, which should create an output file. And here we have the output from the HC method, and it's HC method 3 as a default. If you read the Hayes and Kai paper, you'll see that there are more options than what I just presented to you. And we can see that the point estimate of the unstandardized beta weight is 7.6094. That's unchanged from the original regression analysis. So if I did just a regular regression analysis, I would get exactly the same education in the independent variable box, earnings per day in the dependent variable box. Click OK. Here's the unstandardized beta weight, 7.609, and here's the intercept, 13.9757. These two values are the same as these two values. So the intercept and the unstandardized slope, or beta weight, are exactly the same because these are point estimates. What's different is the standard error a little bit. So look at the standard error for education, 4.344, and that is heteroscedastic corrected. 4.344, 3.447, 4.344. So there is a difference, and the standard error is larger, and that has produced a t-value. So if you just divide the point estimate by the corrected standard error, 7.6094 divided by 4.3445 gives me 1.7515, and that is associated with a p-value of 0.0879. So it is not statistically significant, which is in contrast to the normal theory, normal standard error not corrected for any level of heteroscedasticity at 0.033, but this one's now 0.0879. Now, even though these data had no statistically significant heteroscedasticity, it did have some level of heteroscedasticity. Like, it wasn't like the correlation or the co-anchor test was zero. There was some amount of heteroscedasticity in the data, and the sample size isn't very big, so it's being pushed around a bit here with the application of the heteroscedastic corrected standard errors. So probably maybe you should trust this one a little bit more than you should trust this one. And also, you might recall the bootstrapping also suggested that the correlation wasn't statistically significant because the p-value is greater than 0.05. So here's an example of data that are not perfect. I mean, and that's how data are in real life all too often, is that there's a bit of heteroscedasticity in the data. There's some non-normality in the data. The variables are differentially skewed, and it's having an impact on the results. So this is how you can calculate corrected standard errors. I do mention in the textbook that if you have non-normally distributed data, then this standard error will be impacted by that. We do have some level of non-normality in these data. You might recall that the skew, especially for earnings per day, there was some skew in there. Education was less so. Skew 0.911. That is not a small amount of skew. It's not a terrible amount, but it's not a small amount. And I suspect that's also impacting the results here, and it's producing, that's why the p-value ended up being so different. Now, I mentioned in the textbook that if you're worried about the distribution of data you're dealing with and the possibility that you have heteroscedasticity, you can't really use this technique by Hayes and Kai because it actually does assume relatively normally distributed data. If you wanted greater confidence, you could do something called the wild bootstrap, which is something that you can do more in the bootstrapping utility. And I demonstrate how to do that in the multiple regression chapter rather than here. So if you have a bivariate regression case, the wild bootstrap will work in this context too. I just demonstrate how to do the technique in the multiple regression chapter.